This is ECE41 Communications for Transmission Media in Antenna System and Design lecture. Hi, my name is Jessa Florence M. Gales. I am an electronics engineering student and I am going to discuss jumper cable, multimode, and gap loss. First, for letter J, jumper cable. A short single fiber cable with connectors on both ends used for interconnecting other cables or testing. The application, it is also known as jump leads or booster cables. Jumper cables are a means of restoring voltage to a car's battery, which on its own is not sufficiently storing enough power to engage the starter. As the car fails to start properly, it becomes necessary to use jumper cables in conjunction with a car or a running portable battery. The 4 essential things to know about jumper cables. You may think that all jumper cables are the same, but nothing could be further from the truth. Finding those jumper cables in the bargain bin may seem like a great idea at the time, but the shock that you get from cables that don't have rubber-coated handles will quickly convince you that you should do your research before making a purchase. Learn about the minimum specs for these handy tools, as well as the tips for making the jump safely. First is the gauge and width. Seeing a nice thick pair of jumper cables at the store marked heavy duty can be deceiving. What you really need to look at is the gauge of the cables themselves. Hint: a higher number gauge is not better. A 10 gauge cable will not get you enough juice to jump your vehicle, and a 6 gauge should give you plenty of oomph unless you need to jumpstart a dump track. The lower the number, the faster it will charge and the more power that passes through. Clamp and land. When you go shopping for jumper cables, be sure you're getting a good solid clamp with teeth that don't look like they will slip off the battery terminals. Getting some nice rubber-coated handles helps assure that you won't be a shock. A good minimum length for jumper cable is 12, but even longer would be better in case you've gotten yourself and your vehicle into a crazy location and you need a jump. 3. Starting the jump. You actually need to know how to use them without disastrous consequences. 4. Finishing up. Simply remove the cables in the reverse order, black cable removed first. Next for M is a multimode. A multimode transmits or emits multiple modes of light, an optical waveguide with a much larger core than a single-mode waveguide core, and which permits approximately 1,000 modes to propagate through the core compared to only one mode through a single fiber. How many types of multimode fiber? OM1 fiber typically comes with an orange jacket and have a core size of 62.5 micrometers. It can support 10 gigabit Ethernet at lengths of up to 33 meters. OM2 fiber. Likewise, OM2 fiber also comes with an orange jacket and uses an LED light source but with a smaller core size of 50 micrometers. OM3 fiber. OM3 fiber comes with an aqua colored jacket. Like the OM2, its core size is 50 micrometers, but the cable is optimized for laser-based equipment. OM4 fiber is completely backwards compatible with OM3 fiber and shares the same distinctive aqua jacket. OM4 was developed specifically for VSCEL laser transmission and allows 10 gigs link distances of up to 550 meters. OM5 fiber. OM5 fiber, also known as WBMMF or wideband multimode fiber, is the newest type of multimode fiber, and it is backwards compatible with OM4. It has the same core size as OM2, OM3, and OM4. This color of OM5 fiber jacket was chosen as lime green. It is designed and specified to support of at least 4 WDM channels. Gap loss. The effect of gap loss is a result of signal strength and precision being lost due to the scattering of the light. A fiber optic signal suffering from gap loss is degraded in both quality and throughput. going to be proportional to the ratio of the core radius to the size of the gap or displacement. The three basic types of gap loss is first the angular misalignment loss, power loss caused by the deviation from optimum angular alignment of the axis from source to waveguide, waveguide to waveguide, or waveguide to detector. 2. Lateral offset loss. In fiber optics, the loss of optical power at the splice or connector caused by a lateral, that is transverse offset of the emitting fiber force, which offset causes imperfect transfer of the optical signal from the transmitting fiber to the receiver fiber. Third is the longitudinal displacement loss. Longitudinal displacement losses do not occur in optical integrated circuits, such as are used in computers and control systems. In fiber optic connectors is needed to prevent optical fiber end-phase to end-phase contact that might cause damage to the end phases when making and breaking connections with a connector. Thank you for listening. This is Jessa Florence M. Gales, BSCE 3A. Bye-bye.